Gandang hapon po. Medyo na-delay ng konti. Gandang hapon, Miss Rivera. So, unfortunately, we have to extend, konti lang naman, until next week. In principle, ang classes ay, ang end of the semester, in principle, ang end of the semester is December 19. So, magkakaroon tayo ng time between now and December 19 for our last couple of discussions and our second exam. Gusto ko lang namang ilagdag dyan yung one, philosophy of physics, and two, philosophy of biology. Mag-over lang natin yung philosophy of physics and philosophy of biology, pwede na yun. And then I can give you your second exam. Tapos ang gagawin natin, first exam, the second exam, minus the lowest. Tapos kung anong matira, yun ang basis na ating grade. Yan. Okay, magsasurvey ako mamayang gabi. We'll find out kung ano yung inyong opinion tungkol dyan. Screen share natin ha. Ito yung situation natin. Sabi ko nga, ulitin natin. In-announce ko kanina, ito. Yan. Ano yung in-announce ko? Ito. We are extending our meetings until next week. Yan. Sandali lang ha. So we are extending our meetings until next week, and we are going to have a second exam. The grading is going to be based on a cancel the lowest exam grade system. I'm going to do a survey of all my philosophy classes tonight using Mentimeter regarding this arrangement. So tingnan natin kung ano reaction ng lahat, and then we will adjust accordingly. Yan. Ay, konting hirap lang naman eh. Philosophy of physics, philosophy of biology. Once covered yan, pwede na yan. Yun. Meanwhile, tingnan natin tong ating Mentimeter. The universe is governed by rules. Ano nga ang ginagawa natin? Nag-aaral tayo, in particular, using the scientific method. Anong output ng scientific method? Theories. What are theories? These are sentences that identify some pattern expressed in, therefore, generalizations that are based on enough number of observation, based on representative observation, and based on representative observation with no counter instance. Yan, yung scientific generalizations na yan ang output ng scientific method. We call them theories. And we collect as many theories as we can so that we can predict the future, so we can have control over our destinies. And they are rules. Rules put together, we call that science. The theoretical framework of science. Ngayon, sinasabi natin, yung ating assumption na we can establish such a system called science, a theoretical framework of science, ang assumption is the universe is governed by rules. Yan. Is it possible for some universe to be ungoverned by rules? Ay nako. Hindi ko na ilagay. Sandali. Baguhin natin yung configuration. Pakisagot nga. Pakituloy. Prof. Villa naman. Nakakainis. Tuloy natin. Pakisagot nga. Siya man nagsagot. The universe is governed by rules. So, next question. Possible for some universe to be ungoverned by rules? Pwede bang magkaroon ng, kunyari lang, anti-universe? At sa mundo ng anti-universe, walang rules that govern the anti-universe. Diyan yung makikita yung sinasabi ng mga comics na binabasa nyo, Marvel Comics, DC Comics, na merong galing sa parallel universe. Kaya lang doon sa parallel universe ay baliktad ang lahat na nangyayari. Aba, kung baliktad, ibig sabihin, while we are governed by rules, they are not governed by rules. Pwede ba yun? Parang kung govern tayo ng rules, baliktarin mo, di ungoverned by rules, sila. Pwede ba yun? Possible for some properties of the universe to be ungoverned by rules. Three words that indicate what it means to be ungoverned. Unpredictable, of course. Uncontrollable, of course. Disorder, chaos, wild, random, yes! Yan, mundo nino. Mundo ni Deadpool. Yan, favorite ko yan si Deadpool. Oh, parang 'di ba, ang dami-dami nating napapanood na sine, no? Sinasabi, parallel universe. Okay. Babalikan natin 'yan, Ulitin natin para kita ninyo kasi yung iba nahuli. O yan, universe is governed by rules. Yan ang assumption natin. Kaya tayo nag-aaral ng rules of science called theories. Posible naman na may anti-universe, ungoverned by rules, parang ang hirap isipin. And therefore, kahit na property lang ng some part of the universe, ay mahirap din isipin . And so ito nga, tinatanong natin, what are the indicators we think would mean for a universe to be ungoverned? Yan, random, disorder. Alam nyo ba, may isang professor from MIT. Ang sabi ng professor from MIT, randomness is just a figment of your imagination. We only think there is such a thing as randomness, but actually, from another point of view, what is random may not be random. Well, saka na natin balikan yan. Correction, please. Dine, may nilagay ako . Kakainis . Okay, nilagay ko, Day 21 topic, Philosophy of Physics. Naglagay ako ng PDF files. Yung nilagay kong PDF files, mali-mali yung nailagay ko. So, gagawin ko ng bago, I-erase ko muna to, Anyway, papadala ko sa inyo. Saka ko na lang ipapadala, Mamaya, pagkatapos nitong klase nito, gagawa ko ng bagong PDF file, papadala ko sa inyo. Pasensya na. But meanwhile, ilalagay na rin natin dito, kung may oras kayo, panoodin nyo ito, at dito kayo pupulot ng mga sagot sa examen ninyo . Tungkol sa atoms, yung lecture ni Alcalili, pwede na yan, pero merong mas maganda, kaya lang hindi ko mahanap . Dali The key to the cosmos. Ano ba mas maganda rito? Ito na lang, the key to the cosmos, yan. Yan na lang kung may time kayo, panoodin nyo yan, binago natin. And let's move on. Ito. Ito tayo dito. Glimpse lang ang ating gagawin. Sisilip. Bakit? Masyadong mabigat na usapan ng physics . Si Albert Einstein nga namatay, very frustrated . As in literally frustrated. Alright, glimpse of philosophy of physics. Kasi ganito yung usapan natin . Whether it is physics or biology or art, ang assumption natin, merong domain. Domain ng what we call knowledge. in particular, ang gusto natin pag-usapan scientific knowledge. Pero sabihin na lang natin knowledge at large. And yung domain ng knowledge natin, ang assumption natin is a body of knowledge. And therefore, you call it a body of knowledge. Therefore, the assumption is everything in it is interconnected. Or everything in it are interconnected. Yan. And dahil may interconnection, then there is the possibility of coherence or incoherence. Kasi the moment you presume na may connection, then there is always the possibility of some contradiction. Yan. And throughout the centuries, sabi ng mga pilosopo, pinag-uusapan na natin paulit-ulit, the more coherence you get, that means the less contradiction you get. In other words, the more incoherence that you have, by definition, the more contradiction that you get. And the more contradiction, then the more confusion. In other words, we're saying our capacity for prediction impinge upon by your contradiction. So, bumababa ang capacity for prediction so long as dumadami yung contradiction, dumadami yung incoherence. Conversely, pag dumadami ang coherence, therefore bumababa ang contradiction, therefore tumataas ang prediction. Yan. Therefore, more control over our destiny. And therefore, ang target natin, gusto natin, mas maraming coherence. Yun ang gusto nating mangyari. Gusto nating mas maraming coherence. Yan. Yan ang target natin. So that whenever we see something that contradicts some thought contradicting some other thought, we investigate it. And if we cannot solve it, we try to do away with it in one way or the other so that we can build our capacity for prediction better and better. Yan. So any attempt for coherence, whether it involves physics or biology or chemistry or art, that's what you call philosophy of. Yan. Philosophy of. Yan. Halimbawa, philosophy of sport. For example, philosophy of sport. Pag sinabi niyong philosophy of sport, ang pinag-uusapan ay yung mga contradictions involving sport. Halimbawa, ano yung contradiction involving sport? Sa Olympic Games, walang kinalaman ang gobyerno. In fact, by law, sa Olympic Games, ang dapat members lamang ng International Olympic Committee at representative sa, halimbawa, Philippine Olympic Committee, kailangan walang kinalaman sa gobyerno. Bakit? Kasi governments involve politics and we do not want politics to be involved with Olympic Games. And yet, what is the contradiction? The contradiction is when representatives with the Olympic Games participate, they represent their countries. Guess what? When they represent their countries, they represent political entities. Country, nation, they are all political concepts. So, parang ang labo. Bawal ang politics, pero we represent political entities. Po tayo na. Paano nagkaganon? Contradiction. And trying to overcome this contradiction, then you are involved with philosophy of sport. Yan. Ganon din sa physics. Meron tayong philosophy of physics. At sa philosophy of physics, yan, sa philosophy of physics, meron tayong nakikitang contradictions, gusto nating ayusin. Para kanino? Hindi para sa mga physicists, hindi para sa mga scientists, para sa mga mahilig sa philosophy and the public at large. Now, whether physicists or scientists agree with what philosophers do is their own problem. Ang habol ng pilosopo ay tumulong sa bayan, whether mag-agree ang mga scientists o hindi. Yan. Maliwanag yan, ha? Yung mga scientists kasi, maliwanag na maliwanag, may kayabangan. Kung saan sila magpunta, laging ang sinasabi, kami ang may alam. Alam namin yan. Pagka kayo ay walang alam sa science, hindi kayo papansinin. Kayo ay second class citizen. Ay okay lang yan. Kasi pwede namang magkamali tayo at sila'y tama, walang masama doon. Pero, sa point of view ng mga pilosopo, kagaya ko, ay sige lang, go ka lang, kung yan paniwala mo. Basta ako, maghahanap ako ng coherence sa mundo. Para makapredict ng maayos. Para may control over our destinies. Hindi pa uso yung science, matagal nang gusto ng mga pilosopo yan. Magmula kay Pythagoras hanggang sa panahon ng Renaissance period, maliwanag na maliwanag, habol-habol ng mga pilosopo yung coherence. Kaya nga, dami-dami nating lecture kung saan-saan dyan sa history ng science. Bago pa magka-science, gusto na natin control over our destinies, independent of the gods and the deities, dependent only on our capacity to reason, whether we are dealing with science or philosophy or logic or mathematics or some other thing. So, maliwanag, gusto natin ng control over our destiny. Kung mag-agree ang scientist, okay. Kung di mag-agree, okay din. No problem. Ngayon, punta tayo sa physics. Kasi ang mga pilosopo, hindi lang naman philosophy pinag-aaralan eh. Nag-aaral ng lahat. At kung kakayanin, given time, pag-aaralan din physics. Ngayon, meron tayong na-discover. Kasi, sometime in the 1960s, nagkaroon tayo ng patunay na mukhang one way or the other, mukhang may Big Bang nga yata na nangyari in the past. Big Bang. Yan. Ay anong ibig sabihin ng Big Bang? Ibig sabihin, a long time ago, merong isang unit, ang tawag natin is singularity. Yung singularity na yan, whatever it is, sa buong universe, yan lang ang meron. But for some reason or the other, pumutok yan, nag-expand. At in the process of expanding, lumaki na lumaki ang universe. At nagkaroon ng kung ano-anong forces. And anong nagkaroon? Nagkaroon ng mga forces of many kinds. Kagaya ng anong klaseng forces? Forces that keep the nucleus of the atoms intact. Forces that involve gravity or gravitation, those things. Dali nawala yung aking monitor eh. Sandali lang po. Naloko na. Ano ba nangyari dito? Sandali lang po. Nawala yung aking monitor eh. Sandali lang po. Naloko na. Ano ba nangyari dito? Kailangan may monitor ako para alam ko kung madidinig niyo ako hindi eh. Excuse me. Sandali lang po. Yan. Ay, naku. Okay, sorry. I'm back. Okay, tuloy natin. Hopefully nadidinig niyo ako ha. Okay pa naman tayo, Miss Rivera? Nadidinig niyo ako? Okay, just in case, advice niyo ako. Okay, ganito. Nung nag-expand ang universe, nag-expand ang universe, yung dating isa o dalawang forces lamang dumami. Tapos, nagkaroon din ng mga ano, mga mga klase ng mga particles. So-called particles that exist in the universe. Kung ano man yan, tsaka na natin pag-usapan. Basta yung punto is, merong Big Bang. Noong una, theory lang yan. Yung theory na yan, later on, napatunayan noong 1960s. Kasi noong 1960s, gumawa sila ng isang antena na kung ano man yan. Yung antena na yon na-trace niya everywhere in the universe yung signals ng expansion. Signals ng expansion. Expansion ng universe. At dahil dyan, yung dalawang naka-observe niya, nanalo ng Nobel Prize. Now, anong ibig sabihin yan? Well, for one, yung basis natin ng ating pag-aaral ng non-Euclidean geometry ay mukhang nagtutugma doon sa discovery ng proof for the expansion of the universe. For another, ganito, dumami ang usapan that relates to black holes. Black holes. Yan. Magmula nung 1960s, yung usapan about black holes naging matindi dahil sa discovery nga nung affirmation rather. Kasi dati na nilang tinitirize na affirm lang na mukhang totoo na ang universe nag-expand. Kasi kung ang universe ay nag-expand in all direction, pwede nyo ring isipin na merong baliktad na pangyayari, instead na nag-explode, nag-implode. At pagka nag-implode, nabaliktad yung direction, yan na yung black hole. Yan. In very simple terms, yun ang sinasabi natin, ano? Yan. So, anong ibig sabihin yan? Well, dumating ang panahon na meron tayong mga description of black holes in the form of equations. Yung description ng black holes in the form of equations, ito yung malupit. Bakit? Kasi yung black holes, they involve, for example, entire galaxies. They involve entire nebulae. So, malaking-malaki. Now, put it this way, merong isang black hole, kunyari lang, at everything around it is being sucked into it. Yan. At pag yan ay nangyari, ini-imagine natin na parang sa sobrang lakas ng force, at some point in time, nagkakaroon ng parang singularity dun sa dulo. Parang nabaliktad mo yung Big Bang. Yan. So, parang Big Bang in reverse. Now, ano ang problema? Yan. Ang problema kasi ganito. Pag i-describe mo yung phenomenon of black holes from the macro point of view, Others, point of view where you can see solar systems and galaxies and nebulae, yung description ng behavior ng black holes in terms of the macro point of view, lumalabas na yung mga predictions ni Albert Einstein tama. Kagaya ng magnetic waves. But wag na nating puntahan yung details. Sabihin na lang natin, may mga prediction si Albert Einstein na lumalabas tama. Yan ay based doon sa tinatawag nating general theory of relativity. Imagine general theory of relativity as a system. A system of rules, all connected to one another. And like a system, it is an input-output system. Pag may in-input ka, mag-output ka. At pag nag-input ka ng mga predictions, pag nag-input ka ng data, then makaka-output ka ng predictions. At ang nangyari kay Albert Einstein, ulitin natin, pag nag-input ka ng data, makaka-output ka ng predictions. And ang nangyari kay Albert Einstein, yung mga predictions niya nangyayari as per observation. Pero yan ay from the macro point of view. Pagdating naman doon sa point of view ng micro, in other words, may kinalaman doon sa maliliit na bagay, useless yung general theory of relativity. Pagdating doon sa maliit na bagay, ang tumatama na paliwanag, yung paliwanag ng quantum physics. In other words, mga paliwanag ni na Niels Bohr, for example. Yan. Ito malupit. When we try to reconcile, in other words, general theory of relativity with quantum physics, may problema. So, imagine niyo, ito yung science as a system of theories. Lumalabas yung network of theories ng general theory of relativity at network of theories ng quantum physics. Ayan contradictory. Yun ang masakit. Hindi sila nagmamatch. Parang sinasabi, kung tama ang quantum physics, mali ang general theory of relativity. Kung tama ang general theory of relativity, mali ang quantum physics. Naloko na. Yun ang problema. Yan. Okay. Now, bago natin ituloy ang usapan, balik tayo kay Albert Einstein. Albert Einstein. Actually, kay Albert Einstein na paliwanag, nakakahilo rin. Bakit? Kasi pag susundan natin yung paliwanag niya, lumalabas na halimbawa, sinasabi niya, yung ating concept of gravity ay illusion. Yung ating concept of gravity is misleading. Remember, anong sabi natin? In science, we can reinvent concepts. Di ba? Ang isa sa mga sinasabi ni Albert Einstein, yung concept of gravity, ibasura nyo na yan. There is no such thing as gravity. You only think there is gravity because sanay na sanay kayo sa mga lumang paliwanag sa mundo. Pero sabi niya, better than concept of gravity, dapat ang ginagamit nating usapan ay ano, yung curvatures of space. Curvatures of space and therefore time. In other words, from the point of view of Albert Einstein, kung merong bato na nahuhulog, it does not mean na may force called gravity na nagpupul pababa. Hindi totoo yan. That's only an impression. Yun ang sinasabi ni Albert Einstein. Kasi sinasabi ni Albert Einstein, may curvature ng space and time. Paano natin malaman yung curvature ng space and time if we have a reference as a point of reference in the form of light? If we presume light in any way will always have the same speed under whatever condition, then we can make calculations to show us that space curves and even time curves and therefore is relative. Yan. Now, madaling sabihin pero mahirap maintindihan. Ang sinasabi ni Albert Einstein, illusion lang yan na pagka merong nahuhulog na bato, merong nagpo-pull na force, parang magic. Sabi niya, hindi totoo yan. Yan. It's only about curvature of space and time. Kung ano man, yung sinasabi ni Einstein nung panahon niya, hindi matanggap-tanggap eh. Pero, after a while, kasi nagsimula niyang sabihin niya, 1905 eh. Tapos, 1915, binago niya, pinaganda pa niya. And napag-usapan na nga natin, by 1919, meron ng patunay doon sa mga sinasabi niya. And so, even today, with the discovery of huge magnetic waves coming out of black holes, ay tama pa rin si Einstein. This year alone, no, hindi pala, 2 years ago. 2 years ago, ay maliwanag na maliwanag ang prediction ni Einstein ay nangyayari. So, by now, after almost more than 100 years, yung nung una ay mahirap tanggapin, ngayon pangkaraniwan na at least sa science. Yan. Meron si Einstein na binanggit nung panahon niya. Sabi niya, God does not play with dice. Bakit? Kasi nung panahon niya, may pinag-aawayan tungkol yan sa sa probabilities involving nuclear physics. Pag sinabi niyong nuclear physics has to do with the nucleus of an atom, napakaliit niyan. Noong unang panahon, akala ng mga scientists, madaling ipaliwanag yung behavior ng nucleus ng atom na yan merong protons at meron niyang neutrons and then meron niyang electron na umiikot-ikot sa paligid, parang orbit ng planets. Lumalabas, yung ganyang paliwanag ay kalokohan. Bakit? Kasi merong mga experiment, halimbawa, mga experiment ni na Rutherford, you don't have to remember him so much, pero just in case you're interested, nakalimutan ko na yung first name niya. Yung mga beginning with the experiments of Rutherford, ay napatunayan na ang nuclear components, yan si Rutherford ang nakadiscover ng nature ng nucleus ng atoms eh. Yung nuclear components ng atoms, pag halimbawa napakawalan, in other words, biniyak mo yung atom, yung nuclear components nakawala. Pag yan ay nakakawala, merong isang phenomenon na nakakagulat. Bakit? Kasi on one hand, yung nuclear components, they behave as if they are particles. You know, particle, parang marbles na maliliit, solid material, but at the same time, they behave as waves. Yan. So, medyo problematic yan. They behave as particles and waves at the same time. Yan. Sinisimplify lang natin, ha? Pag meron kang pond, nagtapong ka ng bato. So, yung bato mo pumatak doon sa gitna ng pond. After a while, yung pond magkakaroon ng waves, di ba? At makikita nyo yung waves nagta-travel from the point of view of impact up to the point na yung waves aabot na siya doon sa dulo ng pond. Yan. Now, actually, ang nangyayari sa ganyang pagkakataon, yung mga particles ng water, they remain where they are. Parang sa isang concert hall na merong mga nakaupo na nakaupo ng mga audience. Yung mga audience nagwe-wave. Tumatayo, uupo, tatayo, uupo, may wave, di ba? Pwedeng ganon. Pero yung mga audience, they stay in the same place. But you have a movement of the waves across the audience. Despite the fact that the members of the audience do not move. Ganon din sa pond. Doon sa pond, hindi nagmo-move yung mga particles. They stay in the same place. It is the waves that move. Ngayon, ang gusto nating sabihin, yung concept ng wave is something independent of the particle. Something independent of the atomic components. Yan. So, ito ang malupit. Doon sa mga experiments, beginning with the experiments of Rutherford all the way to the contemporary times, lumalabas na ang nuclear components ng atoms ay on one hand particles, in other words, solid material like your members of your audience in a concert, kunyari concert hall yan at meron ditong superstar na kumakanta, ulitin natin. Ang sinasabi ng mga experiments, beginning with Rutherford experiments, yung mga particles, yung mga nuclear components actually are particles. Very much like the solid material that your audience, that you have in a concert hall. While at the same time, they're also waves. Sabi nga natin, maliwanag sa ating observation, the waves are independent of the particles. The waves are independent of the audience. Kasi yung wave nagtatravel, yung audience nandun, hindi na naalis doon sa kanilang upuan. Ganon din ang sinasabi natin. Yung waves independent of the particles. Bakit? Kasi yung waves nagtatravel, pero yung particle hindi. Yung particle nag-o-oscillate up or down. Nag-o-oscillate siya up or down, nag-o-oscillate left or right, pero hindi siya umaalis doon sa kanyang position in general. Yung wave ang nagtatravel. So you can say the wave travels but the particles do not. So that only means, conclusion, the waves and the particles are different. Pero Yan ay nangyayari pagdating sa mga macro point of view. Pagdating sa micro point of view, microscopic, nuclear, in other words, involving the nucleus of atoms na napakaliit, nag-iiba ang rules. Ang rules, pwedeng particle ka at wave at the same time. Ang gulo. Sa mundo ng singularity, sa mundo ng nuclear physics and therefore sa mundo ng quantum physics, walang mali kung yung isang bagay ay on one hand, particle and wave at the same time. Hindi contradiction ang tawag dyan. Ang tawag nila dyan, it's a natural phenomenon. Pero from the point of view of macro physics, tayo na contradiction yan. Nag-move, nag-travel yung wave tapos yung tao hindi nag-travel. O edi magkaiba yung tao at saka yung wave. Now, kaya na-imbento yung ang tawag ay, excuse me, kaya na-imbento ang tawag ay quantum physics. Panahon din na Rutherford, sinubukang mag-develop na isang physics, isang theoretical system where what is contradiction for mainstream physics is not a contradiction for this kind of physics. Noong 1930s, minority ito. Yung mga naniniwala sa quantum physics, minority. 1930s. Kasi meron tayong concept ng coherence Very classic itong concept ng coherence Given our concept of coherence, something cannot be is and is not at the same time. Yan. In other words, the law of excluded middle, either you're is or you're not. In other words, when you have the sentence P and not P, that is treated as a contradiction. That means there is something wrong. Kaso, sa quantum physics, hindi ganyan. Halimbawa, sa quantum physics, let's talk about probabilities. Yan probabilities. When you deal with probabilities, ganito ang pwedeng mangyari. Pwedeng mangyari na yung isang electron nandito, nandyan yung isang electron, and nandyan at the same time. Kasi 50% ang probability nandito siya, pero 50% probability nandito siya. So, ito ngayon ang problema. How can something be here and here at the same time? Ang sabi ng quantum physics, okay lang yan. Okay to think so. In fact, ngayon, sa CERN, ano ba ibig sabihin ng CERN? Nakalimutan ko na tingnan nyo natin. CERN experiments. Yan. Ano ibig sabihin ng CERN? CERN is the European Organization for Nuclear Research. Yan. Ito Ito kayo. CERN. Ano ibig sabihin ng CERN? Uy, what is the nature of the universe? What is it made up of? Scientists from around the world come to CERN. Yan. To seek answers to such fundamental questions. Using particle accelerations, pushing the limits of technology. So that we will find out what is the nature of the universe, what is it made up of. Yan. Bisitahin niyo yan, ha? Yan, o ha? Accelerators. Yan. Anyway, bisitahin niyo when you have time. Yung mga pinag-uusapan natin, malaking kinalaman sa kanila. Ngayon, dun sa CERN, halimbawa, isa sa mga pinag-uusapan dyan, paano mangyayari na magko-communicate yung isang matter, particle ng matter with its antimatter. In other words, there's assumption that something is here and it will affect something so far away. In other words, ulitin natin. Yung isang experiment sa CERN, gusto nilang malaman, may isang particle na nandito. Pag binombard nila doon sa accelerator, magre-react yan. Pero ang napansin nila, yung isang bagay na ito, pag nag-react, may isang bagay na malayo na nagre-react in a very predictable way. Ang tanong, how can that kind of action affect something that is not anywhere near the original interaction? In other words, action from distance. Action from distance. Meron eh. Sa mundo ng mainstream physics, mundo ni na Einstein. Kasi anong nangyari? Si Einstein naging mainstream eh. By the end of the 20th century, siya na yung mainstream physics. Na nung una ay palaisipan. Pero under the influence of Einstein, sinasabi niya, yung action from a distance is no different from presuming something magical is happening. It's like you're dabbling with magic. Pero, ngayon, eto nga, kita niyo yung website eh, oh. Yan talaga ang usapan eh. Na pag may binombard ka isang particle, automatic, merong antimatter na maapektuhan. So, they don't care whether that's magic or not. They just care na, well, we know this and therefore we can use knowledge of this for development, say, for example, of microchips. You know, a single microchip called M1, yung microchip ngayon ng MacBook Pro, it contains 14 billion equivalent of vacuum tubes. Pinag-usapan natin yan dati. 14 billion. Kaya nila nagagawa yan kasi dahil doon sa mga experiments na ginagawa sa CERN. Among assumptions doon sa CERN are ano yung mga assumptions doon sa CERN? Ito yung mga assumptions doon sa CERN eh. Assumptions ng quantum physics. In simple terms, something can be in one place and another place at the same time in the same breath. Parang, di ba yun? Parang sinabi mong a triangle has more than 3 angles. And sinasabi rin ng quantum physics na Action at a distance is possible. In other words, there are two things, and what happens to one will affect another even if they are so far away from each other, practically unrelated. Yeah. Paano nangyari yun? Yan. Eto pa lang, dalawa pa lang yan. Marami pang implications. Sa makatuwid, yung ating concept of coherence and contradiction, nawawala. So ano ngayon ang gusto nating sabihin ng contradiction? Parang, pag yung contradiction ay binura natin as a useful concept, binura mo na rin yung concept ng coherence. Pag binura mo ang concept ng coherence, eto kinukomplento ni Einstein eh. Hanggang sa namatay na siya. Pag binura mo ang concept ng coherence, binura mo yung concept ng system. Ba't ka pa may system kung may incoherent ka naman? The very concept of a system is dependent on your concept of coherence. Parang, teka, ang gulo naman ng usapan eh. Sa ngayon, pag tinanggap natin ito, something can be in one place and another at the same time in the same breath, which is what quantum physics presumes. Action at a distance is possible. Pag yan ay in-insist natin, then yung ating concept of contradiction, nabubura. Pag nabura yan, yung ating concept of coherence, nabubura rin. Pag nagbura yan, yung concept natin ng system, nabubura rin. Eh ano ngayon? Nasaan na ngayon tayo? Yun ang tanong. Now, dagdagan pa natin. So, may rules tayo. Okay lang ba na ang rules natin eh walang coherence? Okay lang na ang rules natin ay just taken as rules independent of one another? Aba, eh di parang bumalik na lang tayo sa panahon nung mga ancient peoples bago nauso ang geometry. Yan. Nandyan yung usapan eh. Natatandaan ba ninyo? Sinong umimbento ng scientific method? Eh, si Galileo. Ay sinong idolo ni Galileo? Ay si Euclid. Na naging idolo rin ni Thomas Hobbes. Na nag-imbento ng social contact theory. At dahil may social contact theory, dumami sa Europe ang mahilig sa democracy and therefore dumami sa Europe ang mahilig sa science. And by the time you know it, si Newton followed the footsteps of Galileo. Pagkatapos, si Leibniz sumunod din kay Galileo. Pagkatapos, si George Boole, si Bertrand Russell, si Wittgenstein, the Vienna Circle. Hanggang sa Vienna Circle, napaka-influential ng geometry. Hanggang sa ngayon, sa mundo ng artificial intelligence or artificial general intelligence, importante pa rin ang geometry. Yung neural networking, ayan o, very much in the style of geometry. Yan. Ito ngayon ang nangyari, di ba? Nung bago nabuhay si Euclid, ang rules about space, hiwa-hiwalay. They're just rules. Rules considered independent of one another. It is only when eto si Euclid, inspired by Aristotle and earlier Plato, thought about what much earlier Pythagoras has presumed, na merong coherence, merong harmony between all these rules. And so he comes up with what? The elements, putting together all these rules into an inverted pyramid system, whereby on the basis of 5 axioms, you can derive all the rules known to mankind about space. And up to the Vienna Circle, up to the invention of the World Wide Web, yan ang assumption natin. Interconnections in systems the way geometry has moved on. Eh ngayon, ang sinasabi ng quantum physics, forget all that. Naloko na. Ito nga ang situation. Kasi kung lahat ng mga rules ng quantum physics are to be presumed correct, kung ang rules ng quantum physics ay presumed correct, na i-share ko. Kung lahat ng rules ng quantum physics ay lagay natin dito. Quantum physics presumed correct, then ang ibig sabihin yan, anong ibig sabihin yan? Then we have to revise our concept of contradiction. We have to reinvent what we mean by a contradiction. We have to have a concept of contradiction that allows us to say that something can be in one place and another place at the same time. We have to have a contradiction, a concept of contradiction that allows us to say you can be dead and alive at the same time. Now, if we do not have that, then we do not have coherence. There's no way of identifying what we mean by coherence. So, anong mangyari sa concept natin ng coherence? Tingnan nga natin. Wala pa naman tayong problema, Miss Vallejo, Kasi itong aking isang monitor nagkakaproblema eh. Okay. Anyway, so, pag malabo ang concept natin ng coherence, malabo ang concept natin ng system nga. Ano nang gusto nating sabihin when you have a system? Yan. Pero, etong mga practitioners ng quantum physics, adamant. Ayaw nilang bitiwan yung sinasabi nila. In fact, ang sabi ng isang physicist ay ganito. Maganda ang sinasabi ni Einstein, pero mali siya. Pangit ang sinasabi ng quantum physics, pero tama sila. Eh ngayon, anong gusto nating sabihin ng tama o mali? Yun ang tanong. Mali So, anong gusto nating sabihin ng tama o mali? Kung gusto mo sabihin yan, right or wrong, ang point of view ng quantum physics, meron silang kasabihan. Ang sabi nila, compute. Just compute. Well, hindi ko makuha exact yung gusto sabihin yung exact words pero parang sinasabi na, bahala kayo. Basta kami, we will go on with computing and if we are successful with our computation, then okay na sa amin yun. Yan. Parang sinasabi nila, so long as their computation, allows them for engineering advantages, then no problem. Yan. So ang measure ng mga quantum physicists, ito nga, so long as their computations allow them for engineering advantages. In other words, innovations, walang problema. Yan. Ay, mali. Ah. Ngayon tatanungin ko, sandali sulat natin dito. Do you agree with that? Kasi on one hand, tama naman sila, di ba? Nabanggit natin, why do we believe in theories? Why do we believe in theories? Even if they are not true. Yan, sandali May nangyayari dito sa check ko lang Okay, something is wrong with my cell phone, whatever it is. Okay, anyway, balik tayo dito. So far, okay pa naman tayo. So, why do we believe in theories even if they're not true? Kasi sabi natin, because they're useful. Because they are useful. Useful for what? For predicting. Yan ang dahilan natin. Sabi natin, we're not interested in truth. We're only interested in being able to predict. And guess what? Being able to predict, that means being able to come up with engineering advantages. Therefore, innovations. So in some way, tama naman yung mga quantum physicists. But in another way, are we going to say that we're going back to a pre-Euclidean age where coherence is not that important anymore? Medyo malabo, di ba? So, tatanungin ko kayo pakisagot. Dagdagan natin itong ating Mentimeter. Anong idadagdag natin sa Mentimeter natin? Ito yung tanong. It is all right for physicists to give up coherence in favor of practical application. Yes? No? No answer. Sige nga, sagutin nyo nga yan. Tingnan na natin. Tingnan natin nga kung anong sagot ninyo dyan. What do you think? Hintay ako Okay, as I wait, I think I'm going to take a drink. Can we ever give up coherence? Interesting. Well, let me just tell you, from the point of view of philosophy, ang mga pilosopo addict sa coherence That's precisely what happens to philosophy. You try to look for the contradictions and you're happy when you see a contradiction. Why? Because every time you see a contradiction, then that's a challenge for you to be able to become innovative, inventive. Because contradictions, from the point of view of philosophy, once you're able to overcome them, that will lead you, given experience, to a better understanding of the universe and therefore more capability to predict, and therefore, more control over your destiny. Yun. Now, the moment you give up coherence, then that means you will just accept contradictions as mysteries. Yan. And in very simple terms, yan ang issue ngayon sa physics. Pwedeng mas komplikado pa dyan, pero ayaw ko masyadong hukayin eh. Yan. Kaya merong ang tawag eh, Schrodinger's cat. Schrodinger's cat. Yan. Nariya ito. Itong Schrodinger's cat experiment, okay, balik tayo din ha, sa inyo. Dagdagan natin tong usapan dito sa philosophy of physics. Basahin nyo ito ha, tungkol saan, Schrodinger's cat. Kung may time kayo. Yan ha, nilagay ko ulit dyan. Topic sa physics, Schrodinger's cat. Papunta tayo dito. Halimbawa, meron tayong sinatawag na Copenhagen. Ay, naubusan na ako ng space. Sandali. Dami nung pinag-uusapan natin eh. Meron pinag-uusapan kasi, tawag nila Copenhagen interpretation eh. Copenhagen interpretation. Kasi taga-Copenhagen si Heisenberg at saka si ano eh. Si Heisenberg at saka si Niels Bohr. Itong Copenhagen interpretation, sila nga nagsasabi na yung isang particle pwedeng nandito and nandito at the same time. Kunyari, ito yung nucleus ng atom. Yung pwedeng mangyari na 50% probability nandito yung iyong electron and 50% probability nandito at the same time. Sinasabi na, pwede yun eh. Yan. And, ang sinasabi ni Schrödinger, kunyari lang, meron tayong equipment. Whatever it is, that equipment can be connected to the nucleus of an atom. And that equipment is connected to a box. And inside the box, there's a mechanical thing with a hammer. Yan. There's a mechanical thing with a hammer. And when that hammer now gets affected by that mechanical thing, it will break a flask that has poison in it, cyanide. And inside the box, you have a cat. Yan. Inside the box, you have a cat. Whatever that cat is. Yan. Meow, meow. Mukhang daga. But the point is, kasi dun sa Copenhagen interpretation, sinasabi that an electron is here and not here at the same time. Para mong sinasabi, the cat is alive and dead at the same time. Yun ang sinasabi ng Schrödinger's cat. Cat is dead and alive at the same time. Pwede ba yun? Ang gusto nating sabihin, mukhang right between the macro view of the world and the micro view of the world. In other words, the view of the galaxies kung saan very useful ang general theory of relativity at view ng nucleus of atoms ay never na pwedeng mag-match eh. Kasi ang rules dito, hindi acceptable dito. Ang rules dito, hindi acceptable dito eh. Kaya merong gap, big gap between these two views. Ang sabi ng isang physicist, naku, nakalimutan ko yung pangalan. Di ba, next meeting, papakaliwanag ko sa inyo. Yun, si Robert Laughlin, naalala ko na. Ang sabi ng isang Nobel Prize winner, Robert Laughlin, ang sabi niya, this is a question of emergence. Kaya next meeting, pag-uusapan natin emergence. Kasi sabi ni Robert Laughlin, maraming levels of viewing the universe. In fact, there are probably no basic level. Sinasabi niya, in fact, there is no such thing as basic level. Sinasabi niya, no such thing, no proof. Sabi niya, we have no proof that there is a basic level of understanding. Understanding the universe. Yun ang sinasabi ni Robert Laughlin. Bakit? Well, put it this way. Parang ganito. From one point of view, I can see the mountains. And all I can see is just blue mountain. And then I come closer, and I see the mountain with patches of green, patches of brown. But all I can see are patches of green or patches of brown. And then I come closer, I can now recognize patches of brown as in fact agricultural areas and patches of green as forested areas. And then I come closer, I can now recognize the crops of the agricultural areas and the trees of the forest. And now I even come closer, I can even see the leaves of the forest. And then I come closer, I can even see the ants and the bugs and the fungi and the creepy little things of the forest. And I even come closer with my microscope and then I can see the mitochondria of the animals that I see on the ground of the forest. Maraming levels. Each level is called an emergent level. Kasi halimbawa, from one emergent level, you can see the clouds. But actually, if you come closer, the clouds that you see are not really clouds. They are actually water vapors. You point to the cloud, you cannot see the cloud if you come too close to the cloud. From afar, you can see the cloud. You can point to the cloud. Pero pag lumapit ka na sa cloud, hindi mo na siya maituturo. Ibang emergent level ng usapan. Mist ang makikita mo. You can point to the mist or you can feel the mist. But you cannot point to the cloud. So one emergent level, you now conceptualize clouds. Another emergent level, you can now conceptualize mist of the clouds. And then, if you have some way of going about it, you can have another level, the molecules of the water that form the mist of the clouds. Iba-ibang emergent levels yan. At ang sinasabi ni Robert Laughlin, sa universe, you can have a universe of universes. You can have a universe of universe of universes. You can have a universe of universe of universe of universes. So, saan ka titigil? Anong kinalaman nung the way we conceptualize, the way we invent our words doon sa ating nakikita sa universe? Ang sabi ni Robert Laughlin, siguro, yan na nga ang key, understanding emergence. Guess what? Emergence as a topic is originally a topic of philosophy, not a topic of physics. Kaya nagtataka ko, tumputan ng si Robert Laughlin na to, binigyan ng Nobel Prize for talking about philosophy, not physics. Pero Nobel Prize niya, physics. Yan. If you have time, mag-research kayo dyan kay Robert Laughlin. Yung emergence ay malaking topic sa philosophy. Yan ang paboritong topic, for example, na ngayon ay sikat na sikat sa Oxford University, si Paul Humphreys. Tama ba yung spelling ko? Tama yata. But anyway, pag-uusapan natin yan next meeting. Emergence. And like I said, emergence as a topic is actually a topic original to philosophy. Parang parang yung napag-usapan natin, artificial intelligence is an original topic sa philosophy. In fact, it got published in a journal of philosophy, yung paper ni Alan Turing, hindi sa journal ng information theory or physics or anything else. Similarly, yung emergence, ang unang mga publications dyan ay sa philosophy. Pero ito si Robert Laughlin, binigyan ng Nobel Prize, dealing with how emergence affects our view of the universe and therefore physics. So next meeting yan ang usapan natin. But hopefully, ang gusto kong sabihin ay meron kayong background na sa physics, meron tayong very philosophical problem eh. Ano yung very philosophical problem sa physics? Has to do with contradictions and coherence. Aba, pag binura nyo yung concept of contradiction, binura nyo yung concept ng coherence. Pag binura mo yung concept ng coherence, tayo na, walang trabaho ang pilospo. Sayang naman. Pinag-aralan ko nung katagal-tagal eh, biglang useless. Pasensya na po anak ko, sasampu na lang ang natin ang nakikinig. I'll give you a better PDF file containing yung work ni Einstein, maiksing summary at saka yung work ng quantum physicist para makita nyo ano ba yung contradiction between the current ano bang tawag doon, mainstream physics represented by Einstein and his believers and quantum physics. Bottom line is, hindi natin mapagsama yung dalawa eh. Incoherent. Now, next question. Hindi pa tayo tapos. Bago ako matapos. Ang tanong ko ay, is it necessary that at some point we will unify all of physics and all of knowledge known to mankind? Lagay ko sa chat. Is it necessary that we all end up with a unified physics? Unified concept of science? Yan. Yan ang huling tanong natin. Hindi ko sasagutin. Next time na natin sagutin. Now, reminder, magbibigay ako ng survey mamaya. You can say no. Kung palagay ninyong may mali doon sa arrangement, you say it. Because that's what science is all about in the first place. That's what philosophy is all about in the first place. The democratic space for you to say no. Okay? Yan. Pasensya na po. Magandang hapon po. Naku, naubos na naman oras natin. Peace man.